Welcome back. This single rung of logic that you see in front of you is where we left the logic at the end of the last video, but we weren't done with the project, but we wanted to limit the length of time to something around 30 minutes. This is not the only rungs of logic that you have. Let me remind you that you have buffer inputs and you have buffer outputs. And in the sequence, these tags that you're using are not directly connected to inputs or outputs. They're buffered. One change that took place is that I edited the tag names to make them match what's in the manual. For the first two parts of this project, we were using different tag names. I adjusted them to make them match what's in the book. It doesn't hurt anything because it really doesn't matter the IN 0001, 02 and all that. What matters is stop push button, up push button, up limit switch, down limit switch, motor up, motor down, all that stuff. So that's what actually matters. I switched the tags around, and I did that by going to global variables, and you can't do this necessarily online depending on what kind of software you have and what kind of controller. Because you see it's grayed out, but in the offline mode, I went to the alias and typed in a name to match what IN00 was in the manual and so forth for input 00 through 05. I'm going to close buffer inputs and buffer outputs just to clean up. I'll close the Micro800 variables too. That leaves us with just the Micro800 tab and the sequence tab. This is actually our process logic. Very important. I did not emphasize this in the first two video clips, but we are not learning how to program an automatic or a controlled garage door opener. That's not the object of this lab project. The object of this lab project is to become either more familiar with ladder logic or learn how to do ladder logic with Connected Components Workbench using a garage door as an example. The garage door is not the subject here. The logic is. The garage door is just something most people can visualize. It goes up, it goes down. It hits a limit switch when it goes all the way up. It hits a limit switch when it's all the way down. And somewhere near the bottom, there's a photo eye to see if there's anything blocking the door, and you don't want the door to come down. And then there's a stop push button, up push button, and down push button. Everyone can visualize that. This has nothing to do with a garage door opener. It has everything to do with logic, but we're using a garage door example. So our goal here is not to come up with a perfect control for a garage door. Our object here is to discuss logic with something that you can visualize. Okay, so here we have our logic, and it's in a static state right now. It's static because the motor's not going up, it's not going down. And looking at the logic, would you say that the motor had last driven the garage door up or down? In other words, where is the garage door right now? Well, our sensors for garage door position, and we only have two. That's input 4 and input 5. Down limit switch and up limit switch. Those are the two sensors that tell you the position of the garage door. If one of these is true and the other is false, then you know the position. Now, if you're having a hard time remembering how this works, remember that we're using the normally closed contacts of the limit switch in a fail-safe mode, meaning that if there's continuity through the limit switch to the input of the controller, then that's a safe condition. If there was no continuity, then it could either be broken or tripped. We're using normally closed contacts for both the up and the down limit switch as well as the stop push button. If you look at what's true here, and we'll mention the two that don't matter, and that's output 1 and output 0, motor up and motor down. It really should, if you wanted the right grammar, instead of saying motor down and motor up, it should probably say run motor down, run motor up. Because motor down sounds like the motor's down. Well, the motor's not down. Eliminating those two instructions output 1 and output 0. We have 2 that are true. The stop push button is not pushed. The up limit switch is not tripped. Because if it were tripped, then input 05 would be off and this instruction would be false. So when you look at this logic, there is only one condition that can turn on either one of these 2 coils that are starters to run the motor up or run the motor down, and that is input 1, up push button. If you push input 2, I'll do that. See, it goes true, but guess what? The down limit switch, the instruction that's reading the memory location controlled by the down limit switch, that instruction's false because the garage door is already down and it's tripped the down limit switch, which opened the normally closed contacts, and that input went off. True if on input 4, it's false because input 4 is not on. So we can't run the motor down, but we can run it up. I'll push that button. And I don't have to hold it down. I'm just going to flick it real quick. Oh, you did see it go on. Depends on the synchronization between the video card and a bunch of other things. But you won't always see an instruction change state when you have a really quick momentary change of state. In other words, I pushed the button, the input went on, and then right back off when I released it. Anyway, the motor's running up. So what's the first thing that's going to happen when the motor starts pulling the garage door towards the up position? Well, the down limit switch won't be tripped anymore. Now that's true. Now looking at this logic right here, in the state that it's in, there's only one output on, and that's motor up. That means the garage door is on the way up. Looking at the 2 limit switches, input 4 and 5, the down limit switch and the up limit switch, since they're both are true, that means neither is tripped. So that means that the door is in between up and down. Now, if the motor was not running, let's stop it right now. And that's input 0. So I pushed input 0, and you see that it dropped out the motors. Even if you didn't see input 0 go false, I'll hold it down a little bit longer. See, it went false. It only has to be off. In other words, that normally closed push button only has to be open for one program scan when the inputs are updated, and from there on it's a done deal. Before, when we looked at this logic just a minute ago, output 0 was on, which means the motor was up. Both limit switches were untripped, or I should say neither limit switch is tripped. So that means that it was in motion going up, but not up or down. Now, since both motors are off, but both limit switch instructions, they're reading both limit switches. Neither one is tripped, so the door has to be stopped and in the middle. Remember, we're just using this to acquaint ourselves with ladder logic programming and troubleshooting ladder logic programming. If you were troubleshooting this system and you connected your laptop, went online with a program and looked at it, and it says when I push the up push button, it doesn't go up. Well, there's only a couple things that could cause this. One is the up push button doesn't work. It's broken or open, and you push it and the controller doesn't see the state change. Or it does turn on the starter like this. Up is input 1. Okay, now we're the output 00, which through buffer outputs program file is controlling. We'll just go there real quick. See, there's output 00, and it's turning on that module defined bit. However, just because you're feeding most likely 24 volts to the coil on the starter, remember that's a contactor that has big heavy contacts that can switch in a motor that draws a lot of current. Just because you turned on that output doesn't mean that there's continuity from the output of the controller to the coil on the starter. So there's a point where you can have a loss of connection. Then, just because the voltage gets to the coil on the starter doesn't mean that the coil on the starter has continuity and is creating a magnetic field to pull the armature down and close the contacts. Or it doesn't mean that even if you pull the contacts down, that one or more of them aren't burnt or damaged with carbon tracks, build up carbon, and they're not making good connectivity. And even if they are making good connectivity, that doesn't mean that there isn't a wire or two broken between the contacts on the starter and the leads on the motor. And even if that's all good, that doesn't mean the motor's working correctly. So this is just a small piece in the link from you pushing the up push button to seeing the garage door go up. There's certain things you can do when you troubleshoot. You could go in here and look, and I can see the input button going true. I can see that output going on. I can go to the controller, look at the LED on the face of the controller, see the LEDs on for that output. I can put a meter on the terminal, see if there's voltage going out. I can go to the other end of the wire at the starter coil, put a meter there and see if there's voltage there, and on and on and on, all the way to the motor. Then, of course, you can test the motor if everything checks out all the way up to the motor, but the motor's still not moving. The next thing that we did, which is roughly page 129. Now, I remember I had you change a few things around to demonstrate something and then change it back. I'm not really too concerned about going over that, just the main project. This should do the trick to operate a garage door with 3 buttons, up, down, and stop. You push up, it goes up until it either hits the limit switch or you hit the stop button. Same thing with going down. However, in order to avoid this situation where we have operator error and they push up and down at the same time, or they push down when it's going up or up when it's going down, we added those true if off, output 1, energize output 0, true if off, output 0, energize output 1. That prevents operator error damaging the motor, damaging the equipment. However, sometimes people get bored and I wonder what will happen if I hold these 2 buttons down. I wonder what will happen if I hold the stop button down and then push the up button and the down button back and forth. See, they just, to entertain themselves, it is possible, I guess, somebody could come up and accidentally push up and down simultaneously. To avoid that situation, we added a little bit more logic to give the operator grief, I guess you could say, if they are playing with the buttons. So I'm going to pause and go offline and then discuss a few alterations. We wanted to explore some ideas, modifications to the logic that could improve the situation with operators with wandering hands working the push buttons to see what they can cause that's different. First thing that we did was we added logic to each push button to disable the push button if the other push button is pushed. That's real simple. We go here, drop in a true if off, and that was the up push button, so we go to the down push button. If you push the up push button and you're not pushing the down push button, then this works normally. So down here we're going to put in the up push button, and there's 2 ways that you can put this in here. Either one work the same, but one of them has a better pattern if you like. So you see I have the up push buttons in the same position and the down push buttons in the same position. So let's save this, download it. I'm going to pause and wait for it to come back up. In line with our logic. Because the door is in the middle, right? In other words, input 4 and input 5 are both on. Our true if on instructions are both true. And if the door was all the way up or all the way down, one of these would not be true. But since they're both true, the door is stopped and somewhere in between the up and the down. Now, because we don't have a real door, then we have the latitude to take as long as we want once the motor is going in one direction to trip the limit switch. I'm going to push the up push button first, and now it's going up. Now I'm going to push the down push button, which is input 2. And notice that nothing happens because output 0 is on. So that rung cannot go true as long as the motor is going up. Now let's stop it. Because it's in the middle, we can now push the down push button, input 2. Now it's going down. Now let's try the up push button, which is input 1. And again, nothing happens. If we push, let's try both push buttons this time. So I'm going to stop it, input 0. I'm going to push 1 and 2 together. It depends on which one you push first what happens. Obviously, we got input 1 push first, otherwise we would not be going up. So I'm going to let go of those two, hit the stop button, and this time I'm going to allow input 2 to go first, then input 1. Okay, see what happened? It depends on which one you push first, which one goes on. It's impossible to push those two buttons, I think. It's practically impossible to guarantee which one's going to be true first. Now, adding the not down push button and not up push button in those locations really didn't do much for us. In the next example, we're going to shift that into a position that gives us a little bit more. So I'm going to save, disconnect, and go offline and make my edits. And what I want to do, I want to add some more logic, and this is going to get ugly, but we'll do it. So I'm going to put a true if on here, and I'm going to put a true if off here. I'm canceling so I can get all the logic in ahead of time, and drag this down to here. Drag this into here. I could take and click on this, Control C, put the mouse here, Control V, and duplicate that. To keep the same pattern that we had here of input 1, input 1, input 2, input 2, we could swap these around and move this over here. That's not what we did in the manual, but I'm going to do it here. So here I can type in IN, and then it's the up push button, and I. So we have type forward. Whoops. I'm just typing in an I, and then everything that begins with I pops up. The whole idea of Get Skinny in the manual was to take and demonstrate a couple things. One was to remove instructions to reduce the width of the rung to make it easier to read on the screen. And the other was to move some of the logic out of that rung into another rung to make the rung easier to read, which is very common. So what we did was, first we had a if up and not down, if down and not up. That didn't work. I mean, it worked in a sense, but if we let go of the buttons, it was still moving. We wanted to make it irritating for the operator if they were monkeying around with the buttons trying to do up and down at the same time to see if they could do something to entertain themselves or even break the equipment so they could take a break, or they call maintenance. That didn't do what we wanted, so we added it over here. I knew it wouldn't do what we wanted, but it was a logical progression in our thinking that we wanted something in series with both of these two instructions. In other words, we wanted something that was ended with all of this that would drop out the whole thing. Well, it didn't. It would drop it out momentarily, but you couldn't release both buttons simultaneously, so one of them was always going to run. Most likely the last one in the logic, which was motor down. We created a new rung that looks at the state of those two buttons and says if up and down, then both push buttons are pressed. And then over here we used true if off, in other words, true if both push buttons are not pressed, or false if they're both pressed, however you want to read it. So let's test that logic. I can do an up, and it goes up, Now if I push down, nothing's going to happen, because remember, our motor up, output 0, true if off instruction in series with the motor down, output 1, is there to prevent that from happening. If I push both push buttons, notice that neither up nor down, and when I let go, it behaves exactly the same way it did before. All we really did was moved our logic out of the main rung into another rung, but we didn't actually change the results. Now remember that I said, pertaining to the previous rung where everything was in one rung, was that as soon as we let go of both buttons, then it stopped because there was nothing there to seal it in. Where would we put something to seal in this condition? I'm going to go offline and make the edits that I suggested, and then we'll be back. Okay, I'm offline. We wanted to seal in something. We start by sealing in our conditions that gave us both push buttons pressed. So I'll move that inside. Then I'll throw an instruction here and type in B, and see it came up as the first choice. Both push buttons pressed. This will work once. I think in the manual I had you download this, try it, so you could see that logically this is moving in the right direction, but it really didn't work, because how in the world would you reset this logic other than putting it in the program mode and back to run, or turning power off and then back on and back into the run mode? It wouldn't reset. So we need something in here to break the continuity, the logical continuity of this seal-in. And specifically what we're going to use is the stop push button. There's a couple ways I can do this. I'll try what I didn't tell you to do. Right click, copy, right click, paste, or Control V. And I want the stop push button over here so it matches the manual. Now we're saying if both push buttons are pushed, we turn on both push buttons pressed, and we seal it in through the stop button. Now remember, the stop button is a normally closed mechanical contact. This instruction is going to be true unless you push the stop push button. What this gives us is it definitely is going to stop any motion from happening with the garage door, and it's going to force the operator to reset the thing. If he wasn't supposed to be operating it in the first place, he may not even realize that the reason he can't get anything to run is because he has to press a stop push button to reset it. So let's download that and try it out. We still have in the actual control rung that uses and if not both push buttons pressed, rung 2, we still have that bit there because that hasn't changed. What we did is change the logic behind that bit. So if you push both push buttons, now I'll push one first and then the other. Push the up first and then the down. You see, as soon as I push the down, I pushed the up so the garage door started going up, but as soon as I pressed the down, then it stopped. And when I let go, even though I'm not touching either up or down push button, that bit in memory, both push buttons pressed, is still on. And so the true if off in rung 2 is false, and we can't run up or down. Now if we push the stop push button, you can say, well, we don't need to stop anything. Well, we're using the stop push button for dual purpose. So you could say stop reset. I wouldn't put that on the button myself. I would just have stop. Push the stop button, and you can see that it drops out that both push buttons press logic and enables that rung again. I am a firm believer when I'm writing code to control a machine that an operator is involved with is to eliminate as much as is possible of the boredom activities on the part of the operator of, well, let's see now. If I hold this button down on the screen, reach over and tweak this button and use one of my feet to go over and trip this photo eye, what will happen? That kind of stuff. I've seen operators doing it. You can't eliminate everything, but you could see that this logic does not only stop the garage door from moving if you press both buttons, but it won't start again until you clear it by stopping what you started, in a sense. We kind of started this section with get skinny, meaning to make the control rungs, rung 2, as skinny as possible to make it easy to read. The next step was to add the safety photo eye, and the safety photo eye, primarily we want to stop the garage door from moving if it's going down. And one obvious place to put it, first of all, it needs to affect primarily this area right here, the motor down. We could put it somewhere in here. The most obvious place to put it would be in series with this seal-in contact. So if you press the down button and the photo eye is blocked, then when you let go of the button, it won't keep going down. But you could still force it to go down on top of something that you don't want it to go down onto. So you really can't put it down here. It needs to be someplace where it will definitely stop the motor from going down anymore. And if you put it in here, then you are making the rung a little fatter or wider, so to speak. What I had you do, lab project manual, and you could put it in here. Remember, the only reason we're not putting it directly in here, and it's not really a bad idea, because you could put it right here saying if it's not already down and the photo eye is not blocked, then turn on the motor. That might be the most obvious place to put it, is in series with these two right here. However, I'm going to go offline and show you where I put it in the manual. Go to connect. Now we're disconnected. Now we're offline. I branched around both push buttons pressed. Two ways you can do it. I wanted to be able to reset it with a stop push button. In other words, I wanted to add conditions to this rung that kept this on so you couldn't start again without hitting the stop push button. For instance, let's say that you were going down and somebody went over and got in the way of the photo eye and the door stops going down. You don't want the door to start going down again unless there's some definitive action on the part of somebody that acknowledges, so to speak, okay, something happened here we didn't want to happen. I'm going to touch a button to acknowledge the problem, and then we can run again. So that's why I added the logic in parallel with both push buttons pressed. This whole rung of logic here was to create a bit that would stay on and keep this from operating up or down until the stop push button had been pressed to reset it. I'm going to go to here and I'm going to drop in a branch around, and around this I'm going to say if output 1, in other words if you're going down, I just typed it in, I didn't bother looking at the screen and grabbing it, and if the safety photo eye has been blocked. Now I put the safety photo eye, we'll put it out here. I was going to put it after output 1, it really doesn't matter. Now this is not a local tag, so the safety photo eye is input 3. Now we have logic that says if you push both push buttons, this is going to turn on and stay turned on until you push the stop button. Or if the safety photo eye gets blocked, when the motor's turned on to go down, then we're going to turn that on and hold it on until you push the stop push button. Now you could have changed the name of this from both push buttons pressed to safeties anytime you wanted to. I'll just leave it that way because that's the way it is in the manual. But we have more than both push buttons pressed now. So let's download this and see what it looks like. I would like to add something about that PE safety. Photo eyes originally came with mechanical contacts in them. A normally open, normally closed Form C contact, and some of them had timers built in for time delays, and they also had a switch for light dark operate. And when you flip the switch between light and dark operate, you get the opposite state change in the contacts based on when the photo eye sees light or when it doesn't see light dark operation. We're not going to get into that. So we right now our photo eye is blocked. So I'm going to turn it off, change the state of it. One thing that I just noticed, and is probably an improvement in version 11, is notice that the color of the text, you probably already noticed it, but because I'm a dyed-in-the-wool RS Logics guy, where the text doesn't change color, I just noticed that if the bit is on, the text is red. If it's off, it's blue. Notice with input 3, our photo eye, instructions false because input 3 is off. Input 3 is on, see it changed to red, and the instruction is false. So right now, we can run the motor down. So we'll do that. We look, the motor's, the garage door is not up or down, so we push the down push button, let go, and it's running down. Now if I were to block the photo eye, input 3, even momentarily, just long enough for you to see it change state and then let it go, you see that it interrupted the logical path to the down motor, but only because the down motor was running. We'll just test that out. There, I'm pushing the up button, see nothing's happening. If I push the stop button, then the up button, now you see it's going up. And if I change the state of input 3 in the top rung, nothing happens because the motor's not going down, it's going up. This logic works really well. So what we have now is we have safeties, so the operators can't monkey around with the up and the down push buttons. If they happen to do both of them simultaneously, the whole thing's going to stop until they push the stop push button to reset it. We also have the photo eye engaged in the logic, so if you're going down and the photo eye gets blocked, then it's going to stop everything. It's going to keep it that way until you push the stop push button to acknowledge that you've cleared the fault. We're not done with this project, the garage door opener, but we have more or less exhausted the instructions that we've discussed so far. We've not really discussed timers, counters, or any of the other instructions that we might want to use, because we do have more functions that we want to accomplish. Namely, we have to control the light. So we can control the garage door right now, but in order to do the light, because remember, even your garage door at home, if you push that button up or down, I mean it's one button, whether it's going up or down, that light turns on in your garage, unless it's burned out like mine is. That light comes on and stays on for a set length of time. We still haven't done that yet. So we're going to end this garage door project temporarily and move on to something else, and we will come back to this later. And of course, right now this one I think is called Pt8c. And when we come back, it's probably going to be part 10, part 11, but it'll still say garage door opener on it. So you'll be able to find it in case you want to skip ahead and see what we did with the garage doors as far as delaying the lamp that illuminates the inside of the garage.